All right, so in this video, we're going to take page 8 and we're going to talk about other percents that we see in other consumer problems. And we're going to start here with a problem about Mr. and Mrs. Rich. And it looks like last year Mr. Rich earned $56,000 annually. And annually just means yearly. That's his salary. While his wife, Mrs. Rich, earned $93,000. They've both been working hard and earned a raise. Mr. Rich now makes $57,680 and Mrs. Rich now makes $94,860. We want to see who had the higher raise. Now, it's easy to go ahead and see that Mr. Rich made $56,000, and if he now makes $57,680, he's got a $1,680 raise. Now, Mrs. Rich, if she went from $93,000 to $94,860, she got a $1,860 raise. So it might appear right here, based on the fact that Mrs. Rich is earning more money now every year, that she got a better raise. However, if we look at the difference here divided by the original, we can see that Mr. Rich, his increase out of his original amount, he got a 3% raise. Mrs. Rich, her raise, the $1,860 out of her original salary, was only 2%. So if you take the difference and divide it by the original, much like we did with discounts when you wanted to see what percent you saved, you can simply take the difference and divide it by the original here, and we can determine here that Mr. Rich actually got a higher raise. All right, when you buy a car, its value depreciates over time. What depreciate means is that it just loses its value. And so if Rhonda bought a car for $15,000 and after 3 years it's only worth $8,000, what is the percentage of decrease in the value of the car? So once again, we can apply this difference over the original formula to a problem like this, and we can see that if it decreased by $7,000 in value out of the original $15,000, when you divide that in the calculator, it's a 0.46 with the 6's repeating. So when we move the decimal over twice, that's 46.6 repeating percent, or about 47%. As you can see, the car has lost about half of its value, a little bit less than half. So what we're talking about right now here, y'all, is called percent of change. And we have seen percent of change problems when we've talked about an item originally costing a certain amount of money, and then it's on sale for a certain amount. And when we calculate the percent of the discount, that is a percent of decrease. So for the first problem here with Mr. and Mrs. Rich, we were calculating a percent of increase. And for the second one here, we were calculating a percent of decrease because the value went down. So there's a couple other ways that we can practice percent of change, all right? So Henry Ford's moving assembly line increased mass production and lowered consumer costs. If you haven't already learned about Henry Ford this school year in history, you will be soon. And with the assembly line, what that did was that meant that we were able to make cars much, much faster. And because we were able to produce the cars so much faster, that decreased the cost of a car for the consumers. So before the assembly line, in 1908, the average price of a car was $9.50. Now, after the assembly line was invented, in the 1920s, the average price of a car went to $2.80. So what was the percentage of change in the cost of a car from 1908 to 1920? So the difference here, if you take $9.50 and subtract $2.80, you're going to get $6.70. So the cars became cheaper on average by $670. Now, if we divide that by the original, we can see that the cars went down in cost about 70.5%, or 71% if you wanted to round it. So that is a huge percent of decrease for consumers. And now that means that the cars were far more affordable. And that's when you start to see the boom in consumers buying cars. All right. You might have already learned about Andrew Carnegie, and if not yet in history, you will be. So in 1901, Andrew Carnegie decided to sell his steel company to J.P. Morgan for $480 million. Now today, that'd be about $13.5 billion. So by what percent has the value of the company increased? So all I did here was write out the $13.5 billion. If you write that out, and then you've got $480 million here, boom. And so if we subtract, we can see that there's a difference of $870 million. Now, it increased in value by $870 million divided by the original worth. So when you divide that in the calculator, we get a 1.8125. And now if we move the decimal over, we can see that this has increased almost 200%. So 100% of itself would mean it's a doubling in value. If you have a value of 10 and you increase by 100% of yourself, let me write this down just in case you need to see this visual. If you have a value of 10 and you increase 100% of yourself, you've increased another 10. So when you're doubling, you're increasing by 100%. So this did more than double, and you can kind of see that there. This did more than double in its value. All right. I think that's it for this page, and now let's flip over. Now at Starbucks, it might only cost them $1.50 to make a cup of coffee, and that might include the cost of the cup, the lid, the coffee itself, labor, things like that. Now they sell the same cup of coffee for $4.50. What is the percent of increase? And in case you didn't know, this situation is called a markup, and this is what companies do. They mark up their prices to earn profits, okay? So we've got that if it only costs them $1.50 to make the cup of coffee and they sell it for $4.50, they sell it for $3 more. That's a $3 upcharge. Now out of the original $1.50 that it cost them, 3 over 150, that's 2. And when we move the decimal over, that is 200% right there, okay? All right. Brian finds a video game for $48.50, and the game is now on sale for $42.68. What is the percent discount of the game? So this is, again, a type of problem that you've seen before, and now here it is mixed in with all these other percent of change problems. And so when we're looking for a discount here, this percent of discount, that's a percent of decrease, all right? So for the problem up above, that's a percent of increase with a markup, and discounts are obviously a percent of decrease. So if you subtract here, we can see that the game is on sale for $5.82 off. And when we divide that by the original cost of the game, we can see that it's actually on sale for 12% off. And obviously that's not the world's best discount. So if you're somebody who's trying to wait and get a good deal, you might want to wait for a better sale. But maybe this game never goes on sale, ever, ever, ever. And for the first time in a really long time when you've been checking, it's on sale, and so you might want to go ahead and buy it. Again, it's all about your decision as the consumer. We just want to make sure that you're comfortable with the math, and then you can make your own decisions. All right, so in this next one, it's again talking about cars depreciating in value. And it looks like we have that Andrea purchased a $20,000 new car that is now worth $16,000 to $16,200 after just 1 year. So by what percent did the car depreciate in value? So it depreciated in value $3,800, and it was originally worth $20,000. So when you divide the difference by the original and move the decimal over, we can see that it decreased 19%. Now, it originally says here as of 2017, and I did go back and double check the statistic, and this is still a pretty relative statistic here. And on average, a new car will lose as much as 20% of its value in the first year of ownership. So if we have a brand new Hyundai Sonata that costs $21,600, and according to this statistic, if it's going to lose 20%, when we multiply the worth of the car by 20%, we can anticipate that on average, it's going to depreciate $4,320. And if it depreciates that much in value, the car would only be worth $17,280. So hopefully you were taking a calculator and doing these problems along the way with me so that you can see how this stuff works. Whoops, let me fix that real quick. So that you can see how this stuff is, how it works in the calculator, and then how you get your answers on paper. And for the last one here, I just want to talk about what's not right versus what is right here. So if Jackson scored 10 out of 15 on an inequalities test, that means his original score is a 67%, okay? Now when he did a retake, he got a 14 out of 15. Now when you divide 14 by 15, you're going to see that now he got a 93%. So what we want to do here to see by what percent did his score increase, we want to take his original score and his new score and subtract them to get the difference. So he increased his score by 26 percentage points. We're now going to divide that by his original score of the 67. And we can see that his score, his grade came up by 39%. All right? Now, notice that's not what you get when you take 93 and subtract 67. So we don't need to just that's not what you're supposed to do here. You're supposed to subtract to get the difference and divide it by the original. And now we can see by what percent of his original score did he come up. Now, a gut reaction for some of you might have been to say, okay, so he just increased 4 points out of 15 questions, 4 questions out of 15 questions. And while I can certainly see thinking that that might be what you do, you're not really taking into consideration the value of his original score and the value of his new score, and then how those two scores compare. Okay, so this is not how we want to approach this problem. We want to calculate the difference of his two scores and divide by his original score. And that concludes the video on pages 8 and 9 for percent of change. Thank you.